Assalamu alaikum everyone. This is Probability and Statistics for Engineers course in the Department of Civil Engineering, International Islamic University. This is lecture number 2 of week 10, and today's lecture is also the continuation of previous lecture. It is data representation in statistics. So let's start with our lecture. Now, as we have left last time, the time series diagram, how to represent some events along a timeline graphically. But before explaining that, we need to also know some important terms that are related to statistics. And in statistics, we have some terms that we use almost in every sub branches of statistics. So one of them is a population and sample. So what is population and what is sample? Like population is a collection of different items of a particular interest are under the investigation. For example, if I say the people living in Islamabad, so or I say people living in Rawalpindi, are more specifically the height, the average height of people living in Islamabad, or average weight of people living in Islamabad. So if I want to determine the average of weights for a people in Islamabad, so it's very difficult for me. It's very difficult for some researchers to collect the data of whole Islamabad. But in statistic, instead of that, we take a sample of that, and a sample of whole population, and that sample should be a random sample. So if I talk about Islamabad, and if I want to check, or if I want to assess the average height of people in Islamabad, so instead of collecting data from just one sector, I will randomly collect data from let's say G11, then G10, and from H11, H10, F11, F10, or I11 or I10 are different sectors in Islamabad. So I will randomly select samples, like I will select around 10 samples from G11, 15 samples from G10, or 25 samples from G9, and from different other sectors as well. So instead of talking about instead of taking whole population, we just take a sample of that. So we can say that sample is basically a subset of whole population. So if a population is represented by P, so a sample is a part of that population. So sample is an observed subset of population. If we represent the total population of Islamabad, that is, let's say 1 million. So if population I consider it 1 million, so a sample might be just 100 people. So its sample is a subset of population, but that sample should represent the whole population. Now there are some other terms that we use. A parameter is a specific characteristic of population. For example, if I say mean of population, or standard deviation of a height of population, or more specifically mean of mean of weight of population, or mean of height of population. So mean is a parameter that is related to the population characteristics. So similarly, if I say mean of sample of 100 people, there are mean of height of a sample of 100 people, so we call it statistics. So we have four terms, which is population, sample, parameter, and statistic. So the parameters is associated with population, and the statistic is related to specific sample. Now, as I said, population sample is a subset of population. So that sample is a part of population in which it take point B, C. So it take randomly different point G, I, and irrespective of the location. So R, U, and Y. But as Z is not a part of sample, because we don't take that part of the population, we don't consider that, but if we take this sample out of this whole population, this will properly represent this whole population. Now value calculated using population data are called parameters. So if we say mean of height, so that if for the whole population, so that is parameters, and value computed from the sample data are called statistic. So a mean of height of sample, so that is statistics. Now example of population are like name of registered voter in United States, income of all family living in Daytona Beach, that is also one place. So if we are considering the income of all families, annual return of all stock traded on New York Stock Exchange, grade point average of all student in your university. So if we consider all student in my university, so that will be a population. So if I say I randomly select 1,000 students from my university, and the 1,000 student, maybe a few from the department of civil engineering, from few from political science department, few from statistics department, few from history department. So if I take the GPA average of those students, not the whole university, then it is a sample. So in that case it's all population, so we consider population. Now okay, I was expecting some example of sample, but that's fine. Sample is a subset of population. Now how do we obtain sample? There are some sampling technique. Here I will just discuss random sampling technique. There are some other sampling technique like stratified sampling, or there is another sampling technique. So I'm not talking about that sampling technique, but I'm just dealing with the simple random sampling. So simple random sampling is a procedure in which each member of population is chosen strictly by a chance. It's not that you strictly have to consider one person and you cannot skip that one, but it's all about, it's a trial. So you just take anyone out of whole population. Each member of the population is equally likely to be chosen. If it is a male, if it is female, it is if he's an old person, if he's is a kid, if he's a young guy. So you can choose anyone out of them. They are all are equally likely to be chosen. So every possible sample of size n object is equally likely to be chosen. So as I have said, in population, that every member is equally likely. So similarly, for a sample to be taken, the every sample should be equally likely. Okay, it's not like you take 100 sample and consider all 100 sample for as male. So it should be equally likely, mean that it should be around 50 male or 50 female, but not exactly 50. It might be 45, 55. So the resulting sample in that case is a random sample. Now let's come to a descriptive and inferential statistics. So there are two branches of statistic. Basically, one is descriptive statistic and another one is inferential statistic. So if you represent this data graphically or in tabular form, or summarize that in the form of table, so that is then a statistic, descriptive statistic. Now if you use the sample and make prediction or forecast and estimate to help in decision making, so that will be known as inferential statistic. So example of inferential descriptive statistic is mean, standard deviation, or graphical representation, or frequency distribution diagram. These are all the part of or all the examples of descriptive statistic. Inferential statistic is simple linear regression modeling, multiple linear regression modeling, Markov chain, which are basically statistical technique for forecasting and prediction. So those in fact we will study about Markov chain and about linear regression modeling later in this course. Remember that there are two basic types of statistic: descriptive statistic and inferential statistic. Now, what we do in descriptive statistic, the steps are: we first collect the data, collect the data in the form of survey, or we can perform some experiments. So we can also perform some experiments uh, to collect the data. Similarly, then after collection of data in the form of survey or experiment, we present that in the form of tables or graph, which I have already discussed with you, that there are different type of graphs. We can use any of that depending upon the data type, and then we summarize that. Like for example, if we have data of height of people, we can take the average height of people by summing up all the height and divide by total sample size. So sample size is the total number of sample which you have collected. Now, what we do in inferential statistic, we make estimations. So estimation of estimating the population mean weight using the sample mean weight. So it's a kind of transformation or translation of sample results into the population results. So so that is estimation. And similarly, hypothesis testing, we will talk about hypothesis testing when we talk about the goodness of fit test. Hypothesis testing is basically the test, or we make some claims that the population mean weight is 140 pounds. For example, we make the claim that the population mean weight is 140 pound. Is it true or false? Either true or false. So if we perform some statistical analysis, and we either accept our claim or we reject our claim. So we define our claims in the form of null hypothesis, and which is represented by H naught, and alternate hypothesis, which is represented by HA. We will talk about hypothesis testing later in our lecture related to goodness of it. So inference is the process of drawing conclusions or making decision about population based on the sample result. So if I take the sample of 100 people in Islamabad, and I say that the average height of people in Islamabad, or average weight of people in Islamabad, is 65 kg. So it's a kind of representation of whole population weight in Islamabad. Now let's come toward time series data. So as I said, we have different type of representation for data. In case of time series plot, what we do, we take the value of time, or I will use another pen. We represent the values of time, let's say 1990, 1991, 1992, 1993. The time on the x-axis, it's not only year, we can also use months, we can also use hours, we can also use seconds on x-axis, but that should be always on x-axis. Time should always be on x-axis. And then we can on the y-axis, we can take for example number of people, we can take number of people on y-axis, or we can also take some more parameter of interest on y-axis. So a line chart, a time series plot, is used to show the value of variable over time. So if we have a variable that is which might be a GPA of a student along semester. So in first semester, second semester, third semester, fourth semester, so the trend of the GPA may rise or fall. So the GPA is parameter of interest or a variable which is showing the value over time. So time is measured on horizontal axis. So that is very important for time series data, that the time should always be on horizontal axis or x-axis. The variable of interest is measured on the variable axis, vertical axis on y-axis. Now there is another way to represent the data, and that is known as stem and leaf diagram. So what we do in stem and leaf diagram, it's a very simple way to see the distribution detail in data set. So we see how much how is the data distributed, and what is the frequency of data. Its method is quite simple. Just separate the sorted data series into leading digit, which is a stem, and the trailing digit, which is lead. I will discuss that with an example. So if we have a data that is in order array, So which it means that if, or in fact, if we obtain some raw data from the field or from experiment, we can arrange it in increasing order. So the lowest one is 21 here we have, and 41 is the highest one. So what we do, we just make a table, and on the left side we make a column for stem, on the right side we make a column for leaf, and take the first digit of number, that is 21, so that we write in stem area, and the second digit we take and we write that in the leaf. So that is for the first one. If we take 21, similarly if we take 24, so we already have 2 in the stem, we just add another one, that is 4 here, and then we another 4, so we add another 4 here. And since if we have the first digit that is other than 2, then for example we have 38, so we take 3 on the stem side and 8 on the leaf side. So if we order this whole data, this will give us a result like this. So we have on the stem side we have 2, 3 and 4, because we only have 2, we only have 3, and we have 4 here, and we have number on the trailing side. So on the for 41 we only have 41, so for on the stem side we write 4, and on the leaf side we write 1. Now how about if we use hundreds digit as a stem? So what we do, we just round off the 10th digit to form the leaf. For example, if we have 613, a number, so we just round it because we can take 6 in the stem size, but instead of 13 we round it toward 10, so 10 we write it 1. And similarly if we have 76, so we can write 7 at stem side, and we have 76 which is rounded to 80, and instead of 80 we write 8. So similarly for 1 2 to 4, it's we can take 12 on the stem size, and to 24 we transform that to 20, and then we write 2 here. So you can see another example here. It's huge data, and then you can simply transform that whole data into stem and leaf diagram. So thank you for now.